Good morning, everyone. So, welcome to another session of image processing. Myself, Dr. R. Sudhir Babu, Associate Professor, EC Department, J. Pullareddy Engineering College, Autonomous Kernel. So, the last class we had discussed about the simple image formation model. So, what is a mathematical representation of a digital image? Right. So, the image f of x can be represented as the product of illumination component and reflectance component. And as far as the discussion concerned, the light source which will produce image of xy is a monochromatic light, and the monochromatic light intensity is represented with the quantity gray level, and the gray levels are set to span in a grayscale. For practical black and white images or monochrome images, the grayscale will be represented as 0 to L-1, where 0 represents black intensity and the white L-1 represents white intensity. Right. Okay. So today we'll discuss the process of creation of digital image. Okay. So we'll discuss the concept of sampling and quantization. So in the olden days, in order to capture the images, the imaging sensors, that is the cameras, so we'll be using the magnetic tapes. So the magnetic tapes. So on the magnetic tape, so the image will be stored, and which is an analog form of an image. And you know that the storing and the maintaining the analog data is a bit difficult task, and we cannot process these analog images in the computer, which is basically a digital system. So analog signal or analog images cannot be processed using digital systems. In order to make the image that to be processed in digital computers, so we need to convert analog image into a digital image. So from the generation, the following a concept of the sampling and quantization in order to convert a continuous or analog quantities into the digital signals or digital quantities. So here also, since image is a two-dimensional signal, we use the same concept of sampling and quantization in order to convert analog image of xy into the digital image. See, from the fundamental definition of a digital image, f of xy is a two-dimensional light intensity function, where xy are spatial coordinates. If the spatial coordinates are discrete and the intensity values, the gray levels, are also discrete, then the image is called as a digital image. So both the spatial coordinates and the intensity or the gray level should be discrete. Then the image is said to be a digital image. So we need to digitize or discretize both spatial coordinates and also the gray level values in order to get a digital image. So the process of digitizing or discretizing the spatial coordinates is called sampling. The sampling is a process of digitization of spatial coordinates x, y, and the process of digitization of the gray levels is called quantization. So if you're able to digitize both spatial coordinates and the gray level values, then you are able to produce a digital image. Now I'll see the concept of sampling and quantization by taking a simple example. Okay, let us assume an image like this. Yeah. So assume an image. This is an image. Yeah, assume this is a analog image where the spatial coordinates are continuous and also gray level values are also continuous. So now we need to digitize this image. Now see so for that, so we'll take a line segment along x direction. So in the representation of image, this is x coordinates and this is y coordinates. So consider one line segment AB along x direction. Now, so let us plot the gray level profile along the line segment AB. See here the background at the point A, the area is white. Okay, now we know that the grayscale will be extending from black to white, black to white. So between black to white, we'll be having different shades of grays, isn't it? So grayscale will be extending between black and white. Right. Now we'll draw the gray level profile along this line segment AB. Now see at this point, the intensity is white. So, okay, let us, this is the edge or border of the image. Let us assume this is point A dash and this is also the border, that is B dash. So between A and A dash, the intensity is white. So this is on the grayscale, the intensity is white, and at A dash, the intensity is suddenly changing to some shade of gray. So from white to some shade of gray. And as we keep on moving along the line segment from A dash to the center, so gray level is changing from a dark gray to light gray. So at this point, let us assume this is C. At point C, we have a certain shade of gray. And as we move along the segment from C to B dash, C to B dash, so the intensity is varying from the lighter gray to dark gray, and at B dash the intensity suddenly changed to white. So this is a gray level profile along the line segment AB. Now, so this can be considered as a simple one-dimensional function, the light intensity function, how light is changing with respect to space. Okay, now so in order to digitize this quantity, so we need to take the samples along. So this is the sampling process. So this is the gray level profile along the line segment AB. Now here we are taking the samples along this x direction. Okay, here so we need to take the samples at regular intervals of time. Okay, right. So here these are the sample values. So small squares actually represents the sample values. So we are taking samples along x direction, right? So even though we have sampled along x direction, but see the gray levels are still continuously varying. The gray levels are still continuously changing. So we need to digitize the gray levels also. That means the continuous grayscale now has to be divided into portions. So here the total grayscale is divided into 8 levels. So this is 1, 2, 3, 4, 5, 6, 7, and 8. And we'll assign a value for each gray shade. This is 0, this is 1, this is 2, this is 3, this is 4, 5, 6, and 7. Right. So now see the spatial coordinate is digitized where we have taken samples along x direction, and also the grayscale is also digitized. Okay. Now see here, see all these samples comes under this shade of grayscale. So only one shade. Okay. Right. So here each sample now can be considered as a pixel of a image. Right. So this is a pixel at this point, at the first point of the line segment, and this is a pixel at the edge of the image at A dash, and so on. Right. So all these pixels has the same intensity value, white. And similarly, now coming to this point, here we have the couple of samples, pixel values, which comes under this level. And similarly, we have the couple of samples which are basically having this intensity and so on. So we have digitized both spatial coordinate X and also gray level values. So result is this. So the result of both sampling and quantization is this. We have all the pixel values. So here each pixel has a specific intensity, and each intensity is represented with a value. So from A to A dash, so all the pixels will have the numbers, this 7 7 7 7. So these 4 pixels have the number 7 7 7 7. So here the 7 actually represents the max intensity of the grayscale. See, the grayscale is represented from 0 to L minus 1. So 0 represents black intensity, and L minus 1 represents white intensity. In our case, we have divided the grayscale into 8 levels. So 0, number of levels are 8. So the grayscale will be extending from 0 to 7. The value 0 represents black, and the value 7 represents white intensity. Okay, right. See, so for all these pixels, the values are the 7 7. So a pixel with a value 7 actually represents a white pixel. And similarly for this pixel, so the value will be, since this pixel belongs to this intensity, so it has a value 1, and these 2 pixels belongs to this level, the values 2, and so on. So between B dash to B, so we'll be having pixel value 7 7 7 7. Here the value 2 represent one shade of gray, so from black to the dark gray, and so on. So if we digitize the one line segment along x direction, so we got a row of numbers 7 7 7 7 1 2 2 and so on, 7 7 7 7. So if we continue this process from top to bottom of the image, and if you take the line segment along x directions at regular intervals of time, and if you convert each line segment into the digital domain, then see, for each line segment we'll get a row of numbers. So if you do the process from top to bottom for the given image, then we'll get a two-dimensional matrix of numbers. So first row, second row, third row, fourth row, fifth row, and so on. So the process of sampling and quantization results a digital image f of xy, which is basically a two-dimensional matrix of real numbers. So the dimension or size of the matrix can be represented as m by n. So this is what is called the digitization process of a digital image. Okay, in the next class we will see how a digital image is represented in the matrix form. Thank you.